In the ancient Greece, the people believed the lightnings and thunderstorms were caused by Zeus to prove his power and provoke fear. This guy right here. The Aztecs believed that Tlaloc, this guy, the mighty god of rain and storms, made them to announce bad times. The Nords had a god named Thor, this guy, who was responsible for the protection of mankind, literally. And also had a hammer here, you can see it, that was amazing, the Mjolnir. Lightnings were probably how humanity discovered the fire, and many other interpretations and appearances in ancient history. As you can see, this phenomena has been in our lives longer and with more value than we think. Even today, as many children and some adults have a really big problem and phobia to them. We can see them as a symbol of danger here. By the way, when you see this, run. Don't get any closer. You can get hurt or worse. Strength and power. This right here. The Nazis called their war the Blitzkrieg, which means the lightning war. This symbol was feared, and it was a symbol of strength. Pretty weird strength, but it was a strength. And also, we can see them as a symbol of speed and heroism, as we can see from the pop culture, when The Flash, one superhero, many others as Shazam, I think. This symbol was appropriated by them to create heroism and power and speed. But what really is a lightning? Well, a lightning is a gigantic electrostatic discharge formed during storms. It's a natural phenomenon. There are different types, many different types, but in general, there are only a few. It's intracloud. I'm going to explain it right here. Right here. Wait. When let's try it right here. This phenomena occurs. Okay, we have intracloud. It is right here. Let me show you. Right here. Here. This is how an intracloud lightning forms. Within the same cloud, as you can see. Then it is cloud to cloud. And this is it. When two clouds collide in a lightning, it's formed between them, like this. But it doesn't touch the ground. Now, cloud to ground. This can happen between two clouds and one cloud, but it mostly does with one cloud, and it's mostly like this. You see? right here, right here. Also, there is volcanic, but that doesn't happen too much yet. It's just only when a volcano goes boom. And also there is ground to cloud. This is really rare, but really, it doesn't happen too much. And well, you can imagine that because how often you see one. Well, these forms of electricity come on the scene like this. Let me show you. A humid and warm current of air flows through the environment, causing a storm, but not only a storm. This storm is formed by a single cloud. Let's see, let's put it in a certain way. It's only a cloud. But this cloud is no normal cloud. This cloud is named cumulonimbus, and it's a very high cloud, which means that here may be pretty cold, and here it will be pretty hot. But really hot. This causes a tremendous cycle. The air creates some kind of, in the down part of the cloud, it is hot, and in the upper part of the cloud, it's cold. This creates a certain flow within the air inside the cloud, making it spin within itself, of course. This makes the particles inside, such as ice, drops of water, or anything else, collide between them, creating charges, positive and negative. Here, you got positive charge, and here you have the negative one. Yeah? That's clear? Well, let's continue. But now it becomes a bit of a problem. Why? Okay, we no longer need this. But we do need this. So, we have this gigantic cloud. And we said that we got negative charge here, right? Well, this is an example when the lighting is cloud to ground. So in here we have, in the ground, we have positive charge. It doesn't seem to be clear. So here we have the positive charge in the ground. So what happens? Well, okay. Now, these charges, with the positive ones and also with the spin that we explained before, like right here, it goes a spin. It creates and creates and creates negative and positive charges, leaving the negative charges here and the positive charges here in the cloud. But then what happens? What happens? You continue to give charges here, negative and positive here. So you continue, the cloud continues to leave the negative charges here in the bottom and the positive in the upper side of the cloud. Here, let me draw it for you. Here. So what happens? These charges arrive to a limit. This limit causes the lightning to appear. Why? Because the negative charges tend to seek for the positive, but these ones, although they seem pretty close, are really, really, really far. Why? Because this cloud, for real, it has an average of, well, it has kilometers and kilometers. These clouds are really, really tall. So it's easier for the cloud to get from here to here than from here to here. That creates the gigantic spark. This spark can, the differential, the difference in potential, it's in average from 100 to 900 millions of volts. This is huge, guys. Also, this lightning right here tends to have an average also of, let me write it here for you. It has from 100 to 900 millions of volts of volts, and also 10,000 amps. This is no joke. This thing, these lightnings are deadly and they are really dangerous. That's why during a thunderstorm, try to avoid open fields. These things are dangerous, and I'm going to explain why. And also try to avoid trees. Normally, during a thunderstorm, the thunder tries to arrive to the positive pole as faster and without any work as much as it can. The law of the minimum effort. For example, if you are in an open field, the tallest thing in the place will be you. And that's why the lightning will try to arrive to you first, because it's a less distance from the cloud to you than the cloud to the ground. You will become a lightning rod, and that, my friend, it's a problem. Why then you cannot be under a tree? This is an easy one. Because if you're here, the tallest thing in the place will be the tree, but the charge, the energy, the electric energy tends to go really wild, so it hits you too. Therefore, you mostly die.